Hey guys, I'm going to go over the 5.12 homework, and that's implicit differentiation again. So I'm just going to start by, it's asking me to find dy dx, so just use implicit differentiation, taking the derivative with respect to x, and so I'm going to use the product rule. So that's going to be the first, which is x, times by the derivative of the second, which would be 2y prime, plus the derivative of the first, which would be 1 times by the second, plus then we're going to have to use the product rule on that term right there. So that's going to be low d high minus high d low, square the bottom, and that's going to be y squared. That's going to be equal to 0. Now, for the sake of not having to deal with a fraction in here when I'm solving for y prime, I think I'm going to multiply everything by y squared. So that's going to turn this into 2xy to the third y prime plus y to the fourth plus 2yx. Whenever I multiply this with this term, that's where the y squared is going to cancel. And that's what I wanted to do. I wanted to get rid of that ratio. So 2y, I'm going to write that as 2xy because that just sounds better. 2xy, and then minus x squared y prime. That's going to be equal to 0. Okay, and then these are the terms that have y prime. So I'm going to factor out a y prime from those terms. Okay, and then I'm going to subtract these terms over here. So that's going to be negative y to the fourth minus 2xy. And then I'll divide. So y prime is going to be equal to negative y to the fourth minus 2xy all over 2xy to the third minus x squared. And let's see what that looks like the most. Doesn't look like this one because we have two terms on the numerator. The only thing that has two terms on the numerator is b. And it looks like if I distribute that negative y in here, I get negative y to the fourth minus 2xy. So these numerators match. If I multiply this x in there, I get the same thing as well. So it's got to be b. All right, let's see, be the curve defined by x squared y equals 4. Which of the following statements is true of curve C at the point 2, 1? So I'm going to look at some of these right here and think about what I need to do here to get my answer. I see relative minimum, relative maximum, decreasing, concavity, y prime, y double prime. So it looks like I'm going to need to find y prime and y double prime at this point right here. So y prime, so I'm going to have to use the product rule. So it's going to be the first times the derivative of the second plus the derivative of the first times the second. That's going to be equal to 0. Okay. And then I can plug in this point right here and see what y prime is, because it's saying y prime is equal to or y prime is less than. So let's see. So let's go ahead and plug in that point. So that's going to be 4y prime plus 2 times by 2 times 1. So that's just going to be plus 4. That's going to be equal to 0. So that's going to be 4. That's going to, don't need to do that. I don't need to factor out a 4. I'm just going to get y prime is equal, 4y prime is equal to negative 4. So y prime is going to be equal to negative 1. So it's not going to be equal to 0, it sounds like. So we know that y prime is going to be less than 0. So let's find y double prime. So we're going to take the derivative of... Let's solve for y prime here. Do I need to? Sure. So that means x squared y prime is going to be equal to negative 2xy, and y prime is going to be equal to negative 2xy over x squared, which means that y prime is going to be equal to negative 2y divided by x. Sorry, not a lot of room. So y double prime, I'm going to have to use the quotient rule, so that's going to be low d high minus high d low and square the bottom. I'm just going to plug in the point right now. So I'm plugging in this point right here. Don't forget that y prime is equal to -1. So this is going to be 2 times by -2 times by -1 minus -2 times by 1 all over 4, right? And so let's think about this right here. 2 times -2 times -2, that's going to be 4, isn't it? 2 times -2 is -4 times by -1 is +4, minus a negative, so plus. So this is going to be positive over a positive number. So this right here is going to be greater than 0. So y double prime is greater than 0. That's got to be option C right here. Decreasing because y prime is negative, and concave up because y double prime is positive. Okay. For C, let C be the curve defined here. Which of the following statements can be true? Okay, looks like we're doing the exact same thing. And so, I'm going to let you guys have fun with that one. All right, 4, consider the curve in the xy plane defined by x squared minus y squared over 5 equal to 1. It is known that the first derivative here, second derivative here, which of the following statements is true about the curve in quadrant 4? So the curve is concave up, curve is concave down, curve is concave up, curve is concave down. Well, I know it can't be A or B because first derivative does not determine concavity, so it can't be those. So it's got to be C or D. And so, so quadrant 4, meaning in quadrant 4, x is always positive, y is always negative. So if I take this right here, d squared y over dx squared is going to be equal to -25 over y is always negative. So if y is negative to the third power, that's still going to be negative. So it's going to be negative something. And so that's going to be positive because you're going to have a negative divided by a negative. So it's got to be concave up. For 5, at how many points on this curve in the xy plane does the curve have tangent lines that are horizontal? So tangent line's horizontal, that means y prime is equal to 0. So, looks like we probably need to find y prime. So, let's take the derivative here. The derivative of that is going to be 2 over 5 x to the -3/5 plus 2 over 5, then y to the -3/5 times by y prime equal to 0. So this is 2 over 5 x to the 3/5 plus 2y prime over y to the 3/5. And that's going to be equal to 0. If I subtract that over there, we're going to have 2y prime. Oh, there should be a 5 right there. 5y to the 3/5 equal to -2 over 5x to the 3/5. Say I divide everything by 2. That gets rid of those. Say I multiply everything by 5. That gets rid of those. So I don't think these constants are going to matter. These constants aren't going to matter. So then I'm just going to multiply this over here. So I'll get y prime is equal to y 3/5, negative y 3/5 over x to the 3 over 5. And set that equal to 0. And so when will this equal 0? It's going to be when, when y equals 0. And so when y equals 0, also x cannot equal 0, or else that's going to be an indeterminate form. Okay, so let's see. When y equals 0, let's go ahead and we got to plug that back in up here because we're trying to find how many points on this curve where y prime equals 0. So that's when y prime, whenever the derivative equals 0, and we found the derivative equals 0 when y equals 0. So let's go ahead and plug that in. So then that's going to leave us with x to the 2/5 is equal to 1. Say I were to raise both sides to the 5th power. So if I raise this to the 5th and raise this to the 5th, we're going to get x squared equals 1. And if I take the square root, I'm going to get x is equal to plus or minus 1. And so that is two values. So 2 values. Yeah. Okay. For 6, given this curve right here in the xy plane, for what value of y, if any, does the derivative of y with respect to x not exist? So let's take the derivative here. We're going to need the product rule. We're also going to need exponentials, if you guys don't remember those. So dx of a to the x is going to be equal to a to the x times by the natural log of a. Also keep in mind that this is with a y though, not an x. So when I take the derivative, that's going to be the first, which is y, times by the derivative of 2 to the y, which is going to be 2 to the y times by the natural log of 2 times by y prime. So that's the first times the derivative of the second plus the derivative of the first, which is going to be y prime, times by the second, 2 to the y, and that's all going to be equal to 1. So solving for y prime, both terms have a y prime. So if I take out y prime, I'm going to be left with y 2 to the y, natural log of 2, plus 2 to the y, and all that's going to be equal to 1. And then I can divide by all of that right there. Natural log of 2 y. Okay. So let's see. So this is going to be y prime is equal to 1 over y 2 to the y, natural log of 2, plus 2 to the y. So given this curve in the xy plane, for what value of y, if any, does the derivative of y with respect to x not exist? So that's going to be whenever, so that's got to be when the denominator is equal to 0. Okay, so when the denominator is equal to 0. So that's y 2 to the y, natural log of 2, plus 2 to the y, and that's equal to 0. So I'm going to factor out a 2 to the y, and I'm going to be left with y natural log of 2 plus 1, when that's equal to 0. 2 to the y is never going to equal 0. Okay? And so it's got to be when this is going to be equal to 0. So y natural log of 2 plus 1 equals 0. So that's y natural log of 2 is equal to negative 1. Divide by natural log of 2. So when y is equal to negative 1 over the natural log of 2, that's whenever it's going to equal 0. So given the curve, does the derivative of y, okay. Oh, so there you go. C. When y is equal to 1 over the natural log of 2. Okay. Alright, I'm gonna stop this video here and do the rest of it in a different video.